Hi guys, welcome back to my channel Learnopedia. Let's succeed. Now in the last video we started with the first chapter of algebra, linear equations in two variables. That was the first part of this chapter in which I have covered the topics basic of linear equations and the first three methods, that is substitution method, elimination method and graphical method. I have decided to cover this chapter in three videos. That is, in the first video, I had covered the three methods and the basics of linear equations. In the second video, that is this video, I will cover Cramer's method and the equations reducible to a pair of linear equations in two variables. These two topics. And in the last video, that is the third video, which I will put in the next week. That I will teach the applications of linear equations. So let's see the Cramer's rule now. Determinant method or Cramer's rule. Now this method was first derived by a Swiss mathematician called as Gabriel Cramer, and hence it was named after his name, that is Cramer's method. So let's see how to solve by using Cramer's method, and this method is easy with respect to other methods, and we can solve the sums by in really very less time. So also a lot of questions are asked in your exams, that is it might be a MCQ of solving the determinant or finding the values of x and y. So let's see how we should solve it by using Cramer's method. And first we are going to see its derivation. Its derivation is a little bit difficult, but it's just for your understanding or just for your knowledge, like how we get the values of x and y. So let's see. Now for the first condition for solving it by Cramer's method is that the given equation should be written in the form of ax plus by is equal to c. Remember this thing, that the given equations should be written in the form of ax plus by is equal to c. Now here they have given two equations, that is a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. This is the second equation. Now another condition for this is a1b2 minus a2b1 should not be equal to 0. Now why they have used this condition, you will get to know at the end of this video. Okay. Now let's start solving these equations and get the values of x and y in the terms of coefficients. So the first equation, we multiply it by b2 here, and we get the new equation as a1 b2x plus b1 b2y is equal to c1 b2. This is the third equation. And the second equation, we multiply it by b1 and we get the new equation as a2 b1x plus b2 b1y is equal to c2 b1, and this is the fourth equation. Now why did we multiply it by b2 and b1? Because we wanted to equate the coefficients of y. Okay, b1, b2. So after we get the coefficients equal, subtracting equation 3 from 4, and we get this we cancel this y terms, that is plus minus y, coefficients are equal, and we get the value of x, and the x value can be written as this thing. Further, if we substitute this value in the given equations, this ones here, then we can get the value of y. So this is the value of x and y. We get it by elimination method, and these it is expressed in the terms of coefficients, that is c1, b1, a1, b2 and all. Okay. Now further, as I said, you will get to know that why we have used this condition here, that is a1 b2 minus a2 b1 should not be equal to 0. This is because in every variable's value, that is after we get that solving equation, after we get this equation, we notice here that a1 b2 minus a2 b1 is there in the denominator of x, while it is also there in the denominator of y, that is here. So if we put the denominator 0, the value of x and y will get to infinity, that we cannot define it. Like anything upon 0 is infinite and we cannot define that value. So they have put this condition that a1 b2 minus a2 b1 should not be equal to 0. Okay, now further we get this we can write this value, that is c1 b2 minus c2 b1 in the form of determinant, like this is called as the determinant, two lines, and in between that we can write the coefficients and solve that determinant and get the values. Okay, and these are the two different determinants. Like in the numerator we call it as dx, and the denominator is common for both the terms, that is x and y here, so we called it as d. Okay, this thing, and the numerator of y is called as dy, and the numerator of x is called it as dx. So further I will tell you how to get this value of like the determinant, and we will find it by solving some sums. Also you will get the MCQs of solving the determinant, so understand it properly. This is just a derivation, it seems a little difficult, but we will just solve it and make it easy. Okay, now we can find the value of x by dividing determinant of dx upon determinant d, and y we get it as determinant of y upon determinant d. So this is how we find it by Cramer's method, and further as I said, I will make it easy by solving sums, and you will get to know more about it. This is just for your knowledge and how we get the Cramer's rule. Okay, so let's see the examples now. So here are the steps to solve simultaneous equations using Cramer's rule. Before moving to the examples, I have wrote the steps here, like how to proceed with the questions. Now first of all, the given equation should be written in the form of ax plus by is equal to c. This is the first condition, and after that, after we have written the equations, then we have to find the values of determinants, these three determinants, that is d, dx and dy. After finding the values of determinants, we have to just put it in this formula, that is x is equal to dx upon d and y is equal to dy upon d, and get the values of x and y. This is so simple that we have to just follow these three steps and get the values of x and y. Okay, no need of multiplying it anywhere, like multiplying any equation and then eliminating the values, nothing to do. We have to just find the values of determinants and get the values of x and y. Okay, now how to form these determinants? Suppose we have two equations, that is a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So these are the two equations. How will you write the determinant d? That is d is equal to determinant. Now for writing the determinant d, just put the coefficients of x and y. Okay, see, first in the first column just put a1 and a2, and in the second column b1 and b2. Just we have to write the coefficients of x and y, that is these. Okay, that is for the d, the generalized term d. Now for writing dx का determinant लिखने के लिए you have to just replace the coefficients of x by the constant coefficients. ओके, ये a1 a2 की जगह पे c1 c2 डालना है, c1 c2 and b1 b2, nothing to do with coefficients of y. Okay, we have just this one. Okay, wait, we have to just replace the coefficients of x, क्योंकि हमें x की वैल्यू फाइंड आउट करनी है, ऐसे याद रखो, that is b1 and b2. Next we have to write the determinant dy is equal to, अभी हमने x की like for finding the determinant dx we just replace the values of coefficient of x. Now we have to replace the values of coefficient of y because we are finding the determinant y dy. So just replacing that, keeping a1 a2, this we have to replace the values of x and y coefficients in this generalized d, okay, not in the previous one. So इधर x के values, x के coefficients constant रखे and we just change the value coefficients of y by the constant coefficients, that is c1 and c2. This is how we form the determinants, that is d, dx and dy. Okay, this is the thing, formation of determinants. And now how to solve this determinants is, wait, just let me erase this. Okay, so here how to solve this determinants, that is if we have d, how we write it as a1 a2 coefficients of x and b1 b2 coefficients of y. Now we have to just cross multiply that, a1 into b2 minus a2 into b1. Remember, a1 into b2 minus a2 into b1. This is how we find the values of determinants. Every determinant, suppose we take dx, how we write determinant dx is c1 c2 and b1 b2. And how we will find this value as, is equal to, either multiply minus this multiplication. So c1 b2 minus b1 c2. So this is how we find the values of the determinants. It will be more clear by solving the examples. So let's move to the examples now. So let's see the examples now. First I have taken the basic determinants to solve so that you will get to know how to solve a determinant. The first determinant is this one, and let's see how to solve this. As I said, we have to cross multiply the terms and then minus them. So 5 into 0 minus 7 into 3. So let's see the what is the value of this determinant. So value of the determinant is equal to 5 into 0 minus 3 into minus 7. So we get it as 5 into 0 is 0 minus 3 into 7, and that minus sign we get it minus 21. Now this minus gets plus and we get the value of the determinant as plus 21. So this is the value of the determinant and this is how we solve a determinant. Okay. So let's see the second example. It will be more clear. Now in this example we have the numbers in the irrational form. So let's see how to solve them. Now the same method we have to follow, that is cross multiply the terms and then minus. So this is what we have to do every time. We get the value as 7 by 3 into 1 by 2 minus 3 by 2 into 5 by 3. Okay, multiplying the numerator with the numerator and denominator with the denominator, we get it as 7 by 6. So 7 into 1 upon 3 into 2. This is what we get. Again we multiply this 3 into 5 upon 2 into 3. Now we could have just cancel this 3, but then we again need to take the LCM. So we are not going to cancel it and we get the value as 15 by 6. So after subtracting it, that is 7 minus 15 or 15 minus 7, we get it as minus 8 by 6. Further reducing it, we get the value of the determinant to be minus 4 by 3. So these were the two examples from your textbook itself, and I have tried to explain it. I hope you have understood it. So let's see now how to solve the two linear equations using the Cramer's rule. Now we have your two equations, that is 2x plus 3y is equal to 2 and x minus y by 2 is equal to 1 by 2. Now as I said, like we have seen the steps before for solving a numerical by Cramer's method rule. That is, first we have to write the given equations in the form ax plus by is equal to c. So the first equation is already in that format, while the second equation is also. But if you want to reduce the second equation to a simple form, that is just remove the fraction terms, then we can multiply the second equation by 2. So after multiplying the second equation by 2, we get it as 2 into x minus y by 2 is equal to 1 upon 2 into 2. Okay, we multiply it on both the sides, right? So we get the equation as 2x minus 2 into y upon 2. That 2 gets cancelled and we get y is equal to 1. So this is the second equation, and the first equation we get as we have is 2x plus 3y is equal to 2. So these are the two equations we have, and we have to find the values of x and y by using the Cramer's method. So first, after writing the given equations in the form of ax plus by is equal to c, we will find the determinants. That is the d. First thing which we wanted to find is d, right? So d is equal to x के coefficients and y के coefficients का determinant. So x के coefficients are 2 and 2 and y के coefficients are -1 and 3. So these are the two coefficients, right? And solving this determinant, we get 2 into 3 minus 2 into -1. So 2 into 3 minus -1 into 2. So what we get by solving this is 2 into 3 is 6. Minus of -1 into 2 is -2. So adding this, 6 minus gets plus, and we get the value as 6 plus 2 is equal to 8. So this is what we get the value of d. Further, finding the value of dx. So how do we write the determinant dx is? We do not write the x coefficients. Instead of that, we write here the constant coefficients. So what are the constant coefficients? That is 1 and 2. So writing here 1 and 2 and writing the y coefficients as they are, that is -1 and 3. So this is the dx wala determinant. Now solving this determinant, we get it as 1 into 3, that is this multiplication, minus 2 into -1, that is this wala term. So is equal to 3 into 1 is 3 minus 2 into -1, that is -2. So minus gets plus, and we get the value of dx as 5. So this is the value of dx. Further, what we have to find is, okay. So further we have to find the value of dy. That is, how do we write the determinant of dy is x के coefficients वैसे ही, and changing the y coefficients to constant coefficients. So x के coefficients क्या है? 2 2. That is, we write here 2 2, and then इधर जो y के coefficients आते हैं उनको हम replace करते हैं constant coefficient से. That is 2 and 1. So writing it, please don't change its order, like the first equation let remain at the same and the second equation be the same. So please don't change the order, it will make your answers differ. So again, finding the value of this determinant, that is 2 into 2 is 4. I'm writing it directly. Minus 2 into 1 is 2. So what we get is 4 minus 2 is 2. And after this, for finding the values of x and y, we have the formulas. That is, x is equal to dx upon d and y is equal to dy upon d. So this is what we have. We can just directly substitute the values of the determinants here now. So x is equal to dx की value क्या आई थी? We got it as, wait just 2 minutes, okay, 5 and d की value is 8. So we got x dx की value as 5 and this was 8. Again, substituting the value of dy, that is 2, and d की value as 8. It can be reduced to 1 by 4. So this is how we find the values of x and y by using Cramer's rule. Now I think you must have got that this method is easy than the other methods, like elimination method, and we save a lot of time. So if it is mentioned you have to use a Cramer's rule in solving the questions, do use that method because it's compulsory, right? And if it is not mentioned, you can use this method or elimination method or substitution method. Graphical method, as I have repeated a lot of times, it is not feasible and you cannot use it everywhere. So just try to stick to these methods, and Cramer's method is the best method. You can solve any question by this method. So let's see the next topic now, that is converting the non-linear equations into linear equations. So our next topic is equations reducible to a pair of linear equations in two variables. Now in this topic what we are going to see is, if we have some non-linear equations, how to convert them into linear equations. Okay, so let's see some examples of non-linear equations. The first is 3 by x minus 4 by y is equal to 8. Now, is this a linear equation? According to me, it's not, because if we take the x term in the numerator, that is, it will get a power of minus 1. And according to the definition of linear equation, we need the power of the unknown variables to be 1. Remember that? So this is what is the condition, and it is not satisfying that condition. So also if we take an LCM here, that is, if we are taking LCM, multiplying this term and multiplying and dividing this term by y, that is, we get 3y upon xy, and minus multiplying this term and dividing it by x, that is, we get 4x upon xy is equal to 8. Now after doing that, we get the denominator same, so we can take this term to the other side, that is, we get the equation as 3y and 4x is equal to 8xy. So this way the degree becomes 2, right? 1 1 and the total degree becomes 2, that is 1 plus 1. Again here they have 1 degree, but this term becomes 2, is having a degree 2. So again it's a non-linear equation. And the second example of such non-linear equation is, suppose we have 6 upon x minus 1 plus 3 upon y minus 2 is equal to 0. So here it is possible that if we take an LCM, we get a linear equation. Okay, so let's see how should we do that. So taking LCM, we get is 6 into y minus 2, multiplying and dividing this term by y minus 2 upon, now I will take the whole denominator, that is x minus 1 and y minus 2. So here it's thoda sa mistaken, it's 1. and here we get it as 3 multiplied by x minus 1. We just made the denominators equal of both the terms and got this equation. After taking this denominator to the other side, it will become 0 as it is multiplied by 0, right? So we get this 6y minus 2 plus 3 into x minus 1. So after multiplying these terms, we will get a linear equation. For this term, it is possible because on the either side it is 0. So it is possible to get a linear equation. And if we have an non-zero term there, then it won't be possible because again we will get a xy term there. So again it will have a degree of 2. So it is not possible. Now we will see how to convert these equations into a linear equation. Okay, so let's see that now. So for explaining how to convert the non-linear equations into linear equations, I have taken two examples, and this is the first example. This is a simple example in which you will get to know what to do for converting the non-linear equations into linear equations. So let's see by solving this sum. Now we have two equations, that is 2 by x minus 3 by y is equal to 15 and 8 by x plus 5 by y is equal to 77. Now in both the equations they are not the linear equations, because as we have shown that we get a 2-degree equation if we take an LCM also. So this is not possible, and we can convert this equation into a linear equation. Now let's see how. Now this equation, that is the first equation, can be written in the form like this, that is 2 into 1 by x minus 3 into 1 by y is equal to 15, and the other equation can be written as 8 into 1 by x plus 5 into 1 by y is equal to 77. So this is the same thing. We have just separated the terms, coefficient and the variables. So it is actually the same thing. Now why I have separated them is, we can write this term as some another variable. Suppose we take a, and this term as some another variable, take b. So they are both are common in this equations. So we can just take two variables and we get another two equations. That is, coefficients remain the same, so just the variable changes. So what we get is 2a minus 3b is equal to 15, and 8a minus plus 5b is equal to 77. What we did is substituted 1 by x is equal to a and 1 by y is equal to b in both the equations. After that we have to just get the values of a and b from this equations, so that we can get the values of x and y. Now how we will get the values of a and b is by using any of the methods we learnt before, that is using substitution, elimination, or we can use the Cramer's method also. So this is how we can solve, and we have converted the non-linear equation into linear equation. If you have noticed that is, we get the degree of a and b as 1, so it is a linear equation. So we have just converted the non-linear equation into linear equation, and we are solving it by using the methods generally used. So let's see. I am going to use the elimination method for solving these two equations. So for that we need to multiply the equation 1 by 4. So multiplying equation 1 by 4. So 4, that is 2a minus 3b is equal to 15. So what we get is 8a minus 3, this is 3, right? So 3 into 4, that is 12b, is equal to 4 into 15 is 60. So this is the new equation which we get. Let's write it as 3. Now subtracting equation 3 from 2. So we just subtract so that we can cancel one variable. Subtracting equation 3 and 4. So just writing it here, that is 8a minus 12b is equal to 60, and 8a plus 5b is equal to 77. So we have to subtract these equations and we get the values changed, signs changed, right, in subtraction. So we just change the signs. This gets minus, cut, plus minus, and this we get it as minus 12b minus 5b is minus 17b is equal to 77 minus 60, and sign of the greater term is minus, so minus 17, right? So we get the value of b as 1 because this minus minus gets cancelled and the 17 also gets cancelled. So b is equal to 1 from this equation. Okay, now the next thing is we need to find the value of a. Now how we will get that is substituting the value of b in any one of the equations. So if I substitute it in equation 1, that is 2a minus 3b, 2a minus 3b is equal to 15. That is we got b as 1, right? So we have to substitute that in this and get the value of a. Now this 2a is equal to 15 plus 3. So 2a is equal to 15 plus 3 is 18, and a we got it as 9. So again we have to substitute these values as we have assumed 1 by x to be a. So what we have done is a की value is a is equal to 1 by x, right? We have substituted it earlier, and b is equal to 1 by y. So again substituting the values of a and b and getting the values of x. So 9 is equal to 1 by x, and b is 1. So 1 is equal to 1 by y. So again by cross multiplying we get the values of x is equal to 1 by 9 and y is equal to 1. So these are the values we get from this of 1 by of x and y. Okay, this is how we can convert a non-linear equation into a linear equation and get the values of x and y. Now this was the first example which I have taken. It was simple to just assume 1 by x as another variable and 1 by y as another variable, and converting it into linear form, and again finding the values of the new variables, then resubstituting it in the assumed one. So this is the method and how should we solve these types of sums. Now I have taken another example, so it is just a tough one, and let's see how to solve this example and you will get an idea here. Okay, so the two equations are 1 by 3x plus y plus 1 by 3x minus y is equal to 3 by 4. This is the first equation, and the second equation can be written as 1 by 2 into 1 by 3x plus y minus 1 by 2 into 1 by 3x minus y is equal to minus 1 by 8. So this is how we can write the equations, and if you notice that this term is same in both the equations, these terms, right?
So we can substitute by another variable. Like if we substitute 1 by 3x plus y is equal to m, suppose, and 1 by 3x minus y is equal to n. So we get the values of the above equations as m plus n is equal to this whole term we have substituted, right? See here. And we get it as 3 by 4. This is the first equation which we get after substituting m and n. And the second equation we get it as, okay, wait. So 1 by 2 into m, then minus 1 by 2 into n is equal to minus 1 by 8. This is the second equation. If you want to reduce it, multiply this equation, second equation, by 2. You will get it as, after multiplying, m minus n is equal to minus 1 by 4. This is the second equation. Okay. Now, next we have to just add these equations. If you notice here, this plus and n minus n gets cancelled and we get the values of m, value of m. So the equations which we got are m plus n is equal to 3 by 4 and m minus n is equal to minus 1 by 4. So after adding these equations, we get that this cancelled, 2m is equal to 3 by 4 minus 1 by 4, that is 3 minus 1 is 2 by 4, 2m is equal to 2 by 4. Now this 2 of the m goes on the another side, that is 2 is equal to 2 by 2 into 4. We get the value of m as m is equal to 1 by 4. Now substituting this value in one of the equations, we get it as m plus n is 3 by 4. This is our first equation. So substituting this value of m in this equation, 1 by 4 plus n is equal to 3 by 4. So we get the value of n is equal to 3 by 4 minus 1 by 4 is equal to 3 minus 1 is 2 by 4. Reducing this term is 1 by 2. This is what we get the value of n is equal to 1 by 2. Now we got what we have substituted as m and n. Let's see. So we had substituted that 1 upon 3x plus y is equal to m and 1 upon 3x minus y is equal to n. So further we just substitute these m and n values and equate it to the what we have taken as the initial values. So see, substituting again the equations, that is 3x plus y, we had considered it as m. So what we got m as 1 by 4, right? And again we had 1 by 3x minus y is equal to n. That we got the value as 1 by 2. So these are the two equations we got, and now we are going to cross multiply it. After cross multiplying it, we get it as 4 is equal to 3x plus y, the first equation, that is if we consider it as a, and this equation if we cross multiply, we will get it as 2 is equal to 3x plus minus y, that we take it as b. Okay, so after getting these equations, we again have to do something for solving these equations and get the value of x and y. So solving these equations, we get adding this equation. So this is 3x plus y is equal to 4 and 3x minus y is equal to 2. So these are the two equations, we add them and this y gets cancelled. So 6x is equal to 6. So x is equal to 1. This is what we get. Again substituting this value in one of the equations. So I substitute in the first a equation, that is 3x plus y is equal to 4. So 3 into 1 plus y is equal to 4. Again we get it as y is equal to 4 minus 3. So y is equal to 1. So this is what we get the values of x and y. This is so simple thing that we have to just convert the non-linear equations into linear equations by taking the common terms as one of the variable, and after that solving the equations, new equations which we get after substituting the new variables, getting the values of the variables, again resubstituting it in the terms which we substituted. So this is a, by telling you in a verbal way it is little difficult, but I think you must have understood, as we have done two sums in this. Just remember one thing, take common what is there and put that value as a new variable, so it would be easy. And this is the last topic of this video, and after that we are going to cover the applications of linear equations in the next video. So as I said, I have divided this chapter into 3 videos, so don't forget to watch that video, it is also important. And if you like the way of my teaching and how I explain it, so please do like, share and subscribe my channel if you have not done it still. And thank you for watching my video.